So, gentlemen and ladies, this drives us into the next week. So what we've been talking about are all of the options for things that can happen in your life, right? The sample spaces, all of the things that can happen. And now we're going to talk about probability, which is what are the chances that those things will happen, right? So the definition of probability is the probability is the measure of the word we're going to put right here, likelihood that a specific event will occur. So here's what I want to talk about. We play that game pig with dice, right? And when we roll the dice, every 6 rolls, I should get a 1 in there somewhere, right? Because there are 6 numbers on the dice. Those are my number of numbers on the dice. And once I sit down, I want a 1 to come up fast, right? So probability is all of the choices. This is all of the options. And this on the top is the ones you want, right? So if we're playing pig and I want to stay in, the numbers I want are 2, 3, 4, 5, and 6. That would be 5 numbers that I like and 6 total options. Every time I roll, I'm thinking to myself, I got a 5 out of 6 chance that what I want to occur will occur, right? There's 2 types of probability that we talk about in math. There is, you're going to write this down, theoretical, and there is empirical. Empirical, I think I spelled that right. Theoretical is the mathy stuff, right? Because here's what we know. We know when I'm rolling that dice for pig, about 1 every 6 rolls, I will get a 1. That is what the math tells us. That's the math stuff. But you guys have seen it where I have rolled like 12 times and no 1 came up. That is empirical, is the real life stuff, right? And we know that the real life and the empirical and the theoretical don't match always at low numbers. So if I am rolling a dice just 5 times, it might not work. But if I'm rolling it 1,000,000 times, the more we roll, the closer this will come to this. And here's what. This, the theoretical, helps us with this. Again, you guys know this about me, raised by a family of gamblers, right? I don't gamble because I don't take joy in it because I got my ass handed to me. But my whole family's good at math because we're good at guessing the odds to help us make a good bet, right? My parents and my grandparents didn't just bet because they were like they were, they could bluff. It was because they were doing the math in their heads and they could figure out what the chances were. Okay, now when we do probability, our answers will come out between 0 and 1. Now this part I need you to be careful of. That means they will show up in one of 3 ways. I'm going to tell you I am going to be okay with any of these 3 ways as long as you are careful. The first way that it can show up is as a fraction. The second way we can do it is to turn that fraction into a decimal. But the best way is as a percent from 0 to 100%, right? Here's what. The reason I like percent the best is fraction, decimal, percent. Sorry. Here's what. If I told you that your dream college that you want to go to is giving you, they are down to 16 applications. Yours is one of those 16. And they're going to pick 5 people out of those 16. You're going to pick 5 out of those 16. My question to you would be, should you be buying a sweatshirt right now? Because you're thinking, oh my God, they're down to 16 people and I'm one of the 5. Should I be buying a sweatshirt? And here's the problem. That is probability. But our brains don't work well with fractions. They work better with decimals and percents. So if you actually did the math out, you would find that you're going to get like 0.31 or 31%. You might not be buying the sweatshirt, right? It's not a bad percent, but it's not terrific, right? So, okay, you know I'm taping. Okay, thanks. So we're going to be trying. So if you want to use fractions tonight, they must be simplified or marking it on the test. If you want to use decimals, you have to round correctly. And if you want to use percent, then I'm your girl, because I like percent. So here we go. Let's do this. Are you ready? So we're going to start nice and easy. We're just going to take a spinner. Are you ready? The first thing that we're going to do on all of these, we're spinning the spinner. So on every one of these answers right here, it's out of 16 numbers, because our little spinner can end on any one of these 16 numbers. Have I lost anybody? Now what we're going to do is we're going to count the options that we like. So on the first one, look at your spinner, count up the multiples of 3. Literally, just count them, and then put that on the top. Do that right now. Did you get 5?
Yeah.
Easy. Do I do my answers as percent? Yes. But if you do it as decimals, that's okay. I mean, as fraction, that's okay. Does 3 go into 16? Okay. Prime numbers. Guess what? 1 does not count as a prime number. God knows why. I know. Think that shit. So any number that only itself will go into besides 1. So count them up. See what you got. It is literally counting. Then put your crumble board, please. Thank you, babe. Here we go. 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime. I think that's it. 1, 2, 3, 4, 5, 6. Would I give you full credit for that answer? No, I would not. Gotta reduce it. Okay, next thing, I need you to go to the side of your paper and write this big. This is one of the keys to this chapter. And you'd think I'd spend more time making it a big deal, but now I do. I didn't used to. There are 2 words that are going to show up. And or. And I need you to know the difference. So I need you to write it really, really big and really, really dark. And is overlap. I will give you an example. I am going to give $50 to every student in this room that is a boy and over 18. Do I have anyone over 18? Do I have any boys over 18? Oh, there you go. Or 18 or over. You get the $100, right? You got to be both. So when it says and, you got to be a boy and 18 or over. Now watch this next one. On the next one, or is everything. And here's what I mean by that. I am going to give $100 right now if you are a girl or you are 18, which means all of the girls get it, and so does Cohen. Are you 18? No. So Cohen and all the girls, right? That's both. So Oh, this is overlap. This is the small part. This is everything. So here we go. Oh, we're not doing that yet. Let's go ahead and we're going to come back to this in a second. Let's jump down to this one right here. Here we go. And then we're going to come back to those other ones. So here we go. We're going to do this problem. Let me move it down a little bit. I'm going to bring this to here. Students in homeroom were asked if they have a part-time job or driver's license or nothing. So the first thing I need everyone to do with your neighbors, how many people are in this class? Count them in this class, in this class, in this class. Count them up. Every number counts. We're going to come back. 4 is included because they're in the class, but they don't have a driver's license or a job. Did you get 25 in class? Yes. Okay, so for all of these, 25, 25, 25, 25, and 25. Okay, so the first one I want you to do with your neighbors, who are the people who have a part-time job? So take a look. They have a part-time job. It's the whole part-time job circle. I will show it to you. It's this whole circle. So if you put 14, you are fired. Okay. Now the next one, no driver's license. So watch what I'm going to do. I am going to color in driver's license. Don't put these kids in. Put in every other number that is not in this circle, right? I want no driver's license. Be careful. If you put 8, I will be mad at you. There you go. Because you got to count those 4 loser kids that don't have a job or a license. That's what I think of you. Then you are 12. Okay, it's going to get a little weirder. Here comes our and, our overlap. A job and a license. Where do they overlap? No, it's overlap. They have to have both a job and a license. Where do they overlap? It is 6. I'm hearing a lot of people say it's 21. It is not. It's the overlap. Now here comes the next one. A job or a driver's license. That is everyone but these sad 4 people. 21. Finally, the last one of these ones, a driver's license and no part-time job. A driver's license? You're so close. So you have to have a driver's license, so it's this, right? But no part-time job.
Oh, I added 4.
Does that make sense? Are we good?
Yeah, so we have realized why it's not 4.
12. Where did I get 12 at?
Oh, good. You know that it's not enough.
What? 84. Oh, sorry. It's these guys? Okay, we're jumping back. And this is where we're going to get weird here. We're not going to do the pencil one. We're going to do number 3, and then I'm going to shut up. But I need you one more time on the side of your paper to write something down. I've been teaching probability for 38 years, and that's crazy to me how bad you guys have gotten as generations of cards, because with phones, you don't play cards as much. So it's weird. It's very gender biased. There are boys who are out there playing poker, but weirdly, not a lot of girls playing poker. So let's talk on the side of your paper about what's in a deck of cards. Number 1, here we go. How many cards are in a standard deck? 52. We don't count the jokers. The cards are split into red and black. And in each red, there are 2 symbols. And in each black, there are 2 symbols. Can anyone tell me what the red symbols are? Hearts and diamonds. Nice. Hearts and diamonds. And can anyone tell me what the black symbols are? Nice. That's supposed to look like a little shovel. That's what a spade means. And clubs, which looks like a clover. There we go. Underneath each of those is 13 cards, because that's 52 divided by 4. And here's where they go. The first 3 we call face cards. They actually have pictures on them. I wish I had my cards here. There is a king, a queen, a jack, and that's my face cards. And then we go numerically 10, 9, 8, 7, 6, 5, 6, 5, 4, 3, 2. And the last one is called an ace. Sometimes it counts as a 1. Sometimes it counts up here. That is on every single deck. On every single one of these. So there are 4 kings. There are 4 queens. There are 4 jacks. There are 12 face cards. Are you okay? I am probably going to put that up on a test because some kids just don't have practice with it. So we're going to do this problem over here, and it's tricky. So the first thing is, I got a deck of cards right there. It's a little magic trick. I'm going to say pick a card, and you're going to pick out of 52. And I want to know, what is the chance that you are going to pick a diamond or an ace? So here's what we want to do. We're taking both together. This is everything. So let's start with the diamonds. How many diamonds are there? There are 13. And one of those is an ace. So I've used up that. So there are 13. Now, how many aces are left that I haven't picked as a diamond? There are 3. And everyone gets a little confused here. I used up one of those aces when I counted the 13, so I don't count them a second time. I have 1, 2, 3 more. So our total number is 16 out of 52. We're going to reduce that into 8 out of 26. We're going to reduce that as 4 out of 13. There we go. That is the beginning of probability. Yay. Goodbye, friends. Cut off.